Hi everyone, Samara here and welcome back to Go DevOps. In today's episode, we're going to see together a basic container lifecycle. So let's dive in and start. Now here we have the lifecycle overview of a container, and it's what we will be going through step by step after. So let's look at this from a different perspective and take an analogy. So imagine a tenant moving into an apartment, and before anyone moves in, there is a blueprint, so the design of the apartment, how it's built, and what it contains. And that's like a container image. Then one day, someone actually gets the keys and moves in. So that's your container being created and started. And while they live there, they use electricity, water, and space. So they interact with their environment, and that's the running state. And sometimes they leave for a while and come back, so like stopping and restarting the container. And eventually they move out completely, so the apartment is empty again, ready for someone else, and that's the life cycle of a container. So now let's map this idea to how containers actually work in real practice. So the first step in the life cycle is the image. So everything starts here, and a container is always created from an image, which is a packaged version of an application. And it includes the application codes, the dependencies, the runtime, and the system configuration needed to execute it. And the image is built ahead of time, typically from a base image, by adding layers that define the final environment. And once it's built, the image becomes a reusable artifact, and you can store it in a registry, share it, and use it to create multiple containers in different environments. And another key point is that the image is immutable, so it doesn't change during execution, and every container created from it starts from the exact same state, and that's what guarantees consistency. So in the life cycle, the image is really the foundation. It defines what the container will be before it even starts. The next step is container creation. This is where the image is turned into a concrete instance on the host. And when a container is created, the runtime takes the image and prepares everything needed for it to run, but without actually starting it yet. So at this stage, an isolated environment is set up, and this includes creating namespace to separate the container from the rest of the system, and defining resource limits using control groups, so C groups. And the file system is also prepared based on the image layers, and a writable layer is added on top. And this allows the container to modify its state during execution without changing the original image. So at this point, the container exists as a fully prepared environment, and it has its own file system, its own isolation, and its own configuration, but no process is running yet. So it's ready but not active yet, and the actual execution begins in the next step. So the next step is starting the container. So this is the moment where the container is launched, and the main process begins execution. So when the container starts, the runtime runs the command defined in the image. So usually it's the entry point of the application. And at this point, the isolated environment created earlier is activated. So namespace are already in place, the file system is ready, and resources has been allocated. So the role of this step is simply to trigger execution. And from here, the container transitions from a prepared state into an active process. So in simple terms, starting the container means launching the main application process and nothing more. The next step is the running state. So this is where the container is actively doing its job. So once the main process has been started, the container enters a continuous execution phase where the application runs normally inside its isolated environment. So at this stage, the container is fully operational, so it can process requests, execute tasks, handle incoming traffic, and interact with other services depending on its configuration. So even though it is running on the same host as other containers, it behaves like an independent system thanks to its isolation through namespace and resource limits. So during this phase, the runtime continuously managed the container resources such as CPU, memory, and networking to ensure stable execution. So if everything goes well, the container simply keeps running as long as its main process is alive. The next step is stopping and restarting the container. At some point, a running container needs to be controlled, so either to stop it completely or to restart it. And when a container is stopped, the runtime sends a signal to its main process to terminate it gracefully, and this allows the application to finish ongoing work, to release resources properly, and to shut down in an orderly way. And once the main process ends, the container stops running and moves out of the active state. Restarting follows a slightly different flow, so the container is first stopped and then started again using the same configuration, and this allows the application to recover from failures, apply changes, or simply restarting its execution environment. And it's really important to understand that stopping a container does not delete it, it only halts its execution, and the container can be started again as long as it still exists. So this step is really all about controlling the lifecycle of a running container, so either stop it or start it. The final step is termination. So this is when the container reaches the end of its lifecycle, and termination happens when the container is no longer needed or when its main process has fully completed its task and will not be restarted. So at this stage, the runtime ensures that all resources used by the container are properly released, and this includes CPU allocation, memory, network resources, and any temporary file system data that was attached to the container during its execution. And once the container is terminated, it no longer runs as an active process on the system. However, it is really important to understand that termination does not always mean that it will be immediately deleted. So the container may still exist in a stopped state depending on how it was managed, but it is no longer active. And this termination step is really the final cleanup phase, where the system frees resources and closes the life cycle of the container. So that's it for today's video. So we've seen how a container goes through its full life cycle from image creation to the termination. And the key idea here is simple. The container is not just a running process. It really follows a complete life cycle that defines how it is created, managed, executed, and removed. And once you understand this flow, everything in containerization becomes much simpler. And if you enjoyed this video, don't forget to like it and to subscribe, and see you in the next one. Thank you.